First up is the amazing Dr. Noah Petro talking about LRO perspectives for Artemis crewed observation. So take it away, Noah.
Thank you, Kelsey. I'm not sure I'm amazing, but I am caffeinated and very happy to talk to this group about some of the things that we might lean on for Artemis crew observations, starting kind of thinking with what's going to happen for Artemis 2 and beyond. Let's go to the next slide, first slide. So, in putting together this talk, I like to sit and think about, well, what are some of the things that LRO has done that might warrant crew observations? And so I just started with, hey, what are some of the really amazing things that this mission has done over the last 14 years? Whether it's characterizing some unusual new features previously unrecognized or under recorded on the lunar surface, whether it's making the first measurements of particular other kinds of measurements or particular lunar features, or a better understanding of the lunar surface. And I think with that list, it helped me at least start with saying, well, what are some of the things that potentially crew observations could help characterize? Keeping in mind, we have this incredible data set from LRO, 14 years of observations, the largest database collected by any planetary mission ever. What more can be done from orbit? And as we talked about in the earlier sessions, potentially just with crew, just with photography, hey, what can we build on there? If we go to the next slide, please. So again, I'm approaching this from the mindset of, LRO has set a completely new stage for our understanding of the lunar surface and its environment. What do we think we could do that would build on that, not be redundant with, not merely fill up crew time, but really add to our understanding of the moon? And of course, we've talked about, well, what kind of cameras are going to be used? Could there be externally mounted hardware? I'm really thinking of what can be done by crew inside the crew capsule during a flyby. We also have to keep in mind that the moment a human clicks the shutter on a camera to take an image, it is more than just another piece of data. There's a story behind it. And so far for Artemis 2, Kelsey and I have been working with public affairs liaisons at headquarters to understand, hey, how can we lean into these photographs, these images, these crew descriptions to help not just understand the lunar science behind what they're trying to do, but also use it as a stepping stone for the public to get more engaged in the things that we're doing. And so throughout this process and future Artemis missions, working with public affairs, because whether it's a moonrise, an Earthrise, or Earthset, or a particularly stunning image, there's clearly going to be broader scale interest than just the lunar science community. And again, other opportunities, other places to look for what other instrumentation could be taken along in the crew cabin, mounted externally. We won't address that here today. Next slide, please. So again, in thinking through kind of what the possibilities are, I think it's important to set up a foundation of what is realistic. As we saw in Mark's animations earlier on, some of these are going to be very short flybys. Some will be done from either relatively close or at significant distance. And each of those different parameters, regardless of window quality, regardless of anything else, but the parameters of the actual flyby itself lead us to several different kind of scenarios. We might be flying past the moon over an hour, as Artemis 2 will, or Apollo 13 did, for instance, back in 1970. Or if we have extended periods of time in orbit, that opens the doors to other opportunities. If we're in low lunar orbit or in a distant orbit, those will have different science goals that we might be able to address through those different factors. Again, thinking along the lines of what could be done for Artemis 2, may be very different from a subsequent Artemis mission, but still set the stage for kind of what we can reasonably expect from those opportunities. Let's go to the next slide, please. So again, I always like, particularly when thinking about the moon and thinking about our exploration of the moon, is to sort of set the stage for what was done in Apollo, and for anybody on these meetings, and certainly all of the early career people, I would highly recommend either getting digital copies of or paper copies of some of the preliminary science reports, whether it's the analysis of Apollo 8 and 10 photography and visual observations, or the subsequent mission reports, because in those reports are a wealth of information of what was done in Apollo And what was done with images? What was done with crew observations to help understand the lunar surface? We're now in an environment where we're less worried about, well, we need topographic information from craters, where effectively in Apollo era they weren't. But there are still valuable things that can come from simple images taken by crew, well calibrated cameras, and understanding where and what the crew is observing. All you have to do is listen to the crew conversation around the time of the Earthrise image capture on Apollo 8 to hear Bill Anders describing the lunar surface, or the nearly endless discussion of lunar surface geology that Jack Schmitt provided on orbit from Apollo 17, or any of the command module pilots that had on any of the missions, to hear kind of the nuggets of information that are buried in crew observations from orbit. I'll also note that on 3 occasions, crew members on orbit observed impact flashes. And I think there's going to be a great opportunity, particularly if and when we get to I shouldn't say if, when we get to the point of having a seismic package deployed on the surface in multiple locations to help identify flashes and potentially look for the seismic signal of those things. And lastly, crew observations of surface color. Every Apollo mission had a different take on what the color of the surface of the moon was. There's a 1973 GSA paper on Jack Schmitt's identification of color terrains on the near side, something we'll definitely lean into for far side observations by Artemis II crew and subsequent crew members. Next slide, please. So again, whether it's a near flyby, a far flyby, there's going to be many limitations on how much time we have, but we're going to take each moment to really lean into images, crew observations to describe color, to describe subtle variation in hues across the surface. Of course, now we have, thanks to the wide-angle camera, LROC's wide-angle camera, we have global HAPKey parameters, HAPKey color parameters for the entire surface. So we have a sense of what we might expect. But until we get the most sophisticated science experiment sent into space, that's well-trained human eyes looking on the surface, we'll be able to go and verify, validate some of our assumptions about what the color of the far side of the moon looks like. Again, there are going to be opportunities on Artemis 2 and subsequent missions to observe the naked eye surfaces that have never been seen by humans before. And with that, we'll be able to potentially unravel and identify interesting stratigraphic relationships, if the orbit allows, to identify unique morphologies. And again, going through some of the Apollo observations, I'm constantly stunned at some of the quality of the images. And of course, what can be distilled from that. Let's keep in mind, for every oblique image that LROC takes, the narrow angle camera from LROC takes, requires not only planning, but is specifically carried out for single objectives. A crew member on a low flyby over the moon can take multiple oblique images without having to concern for thermal violations or power violations on the spacecraft. And so leaning into the opportunity for multiple low angle oblique images, for instance, on close approaches, is certainly something that we're going to want to do. At right is a Ernie Wright animation showing a flyby similar to what Mark showed earlier. And whether or not we're flying over illuminated moon or unilluminated moon, again, looking for impact flashes, potentially any scattered exospheric dust, which again, LRO has not found any evidence for, but trying to recreate the Apollo 17 observation of Gene Cernan certainly would be something that we could attempt given the right parameters. Let's go to the next slide, please. So, in my mind, there are maybe 4 primary, very very simple initial observations that we could make looking for color differences. Again, Jack Schmitt in his observation noticed that those color differences were harder to discern from significant distance, but in particular orbital configurations, we may be able to have crew members identifying hue differences, color differences across the surface, of course, illumination geometry dependent. Anytime we're flying over unilluminated lunar surface, looking for impact flashes is certainly something that could be done on a short time scale. Statistically speaking, it's not likely we'd be able to see some, but if you don't look, you have no opportunity for discovery. Whether you're in a low orbit or have low angle illumination conditions, looking for variations in stratigraphy, identifying morphological variations. Again, things that we may have just not yet gotten a chance to observe yet with LRO data, certainly something that we could attempt. And lastly, observations potentially trying to characterize the dust environment. Again, low likelihood given the LRO results, but something that could be worth attempting. Let's go to the last slide here and my sort of walk-off slide with 15 seconds to go. We want to leverage and build on the LRO data, and really set the stage for subsequent crew observations. I think there's valid science to be done by crew members, and again, sending well-trained human observers to any planetary surface will result in spectacular results. With that, I'll conclude, and thank you for your time.